day, everyone, and welcome to this new Wi-Fi 360 Prime interview. It's my pleasure to welcome today Bernie McKibben, who's distinguished technologist at CableLabs, to discuss an important question, and that is the coexistence of LTE and license, as it is commonly called, versus Wi-Fi. Hello, Bernie. How are you today?
I'm doing quite well. Thank you very much.
Can you tell us who's CableLabs, what's your mission, and what you do there, please?
Yes, certainly. And thank you very much for the opportunity to be on Wi-Fi 360. It's a pleasure to talk to you. So CableLabs, we're a nonprofit research consortium development, and our mission really is to bring new technologies to the cable industry and our member companies. We're funded entirely by our cable operator members, and our vision is really to deliver innovations to our members in their choice of markets. And so that's why we exist.
All right. And what do you do there personally?
I'm a distinguished technologist, so I really focus on new technologies within our advanced technology group. So evaluating new technologies, how they might be applied to cable networks or in subscribers as a whole, really.
Great. All right, let's move on and dive into the subject here. What is LTE-LAA? There's a lot of confusion about terminologies and terms used. And what kind of deployment scenarios do you envision for it?
Yes, so license-assisted LTE is actually the formalized name of the technology being developed at 3GPP. And it's sometimes commonly referred to LTE-U, but specifically it's license-assisted LTE. And the reason for that name is that how it works is that the traffic channels of LTE are applied in unlicensed bands, the bands that are commonly used for Wi-Fi, specifically 5 gigahertz. But the LTE control signaling remains in the licensed band. So you need licensed technology in order to apply the traffic channels to the unlicensed band. And why would you want to do this? Well, it has several benefits. Vendors who are producing the technology estimate that it have a substantially greater efficiency, potentially in Wi-Fi for certain deployment scenarios. Also, it promises to have easier integration into the mobile core network. For example, the 3GPP, EPC, and the eNodeB RANs. So it provides greater innovation in the mobile network. They're working on different channel sizes for the technology. They'll probably start out with 20 megahertz that could fit within the 5 gigahertz unlicensed band, but also incremental 40 megahertz, eventually up to 620 megahertz channel sizes, which is big enough to consume the entire Uni 1 and 3, which is the most commonly used bands within 5 gigahertz. Some of the deployment scenarios, it's a fairly flexible, potentially could be a very flexible technology, depending on how the standard works out. You could see it envisioned being used in outdoor scenarios, within the enterprise, potentially even within multi-dwelling units in people's homes. So it could have some wide applications.
All right, excellent. Let's dive into then the big question of, can Wi-Fi and LAA coexist? And what's your views on that?
Yeah, it's an excellent, really an excellent question. And I think this is one of the challenges to come up with a strong coexistence requirements for license-assisted LTE. And so some of the characteristics we would be interested in would be fair and equal access to the shared spectrum, so that all operators, all technologies, and all users can have a fair access to that unlicensed spectrum. And this would envision aspects of managing co-channel interference. So if there's multiple users, multiple LAA networks or LAA and Wi-Fi networks on the very same channel, there's a methodology where they can all share that same channel. And we think coexistence should be quantified, and therefore we'd be looking for performance metrics in terms of at least latency and throughput in order to find how well the coexistence works amongst all the players in the band. We also think that in-device coexistence is important, so as a consumer, if I have my smartphone, I'm used to being able to take a look at my Wi-Fi connection manager and see all the networks in the area, the SSIDs. So when my device is in LAA operation, I still would like to see, as a user, see the Wi-Fi networks within that band to have a selection of potentially Wi-Fi service. We also think it's important for a single standard globalized solution because that maximizes interoperability and also produces greater economy of scale across the entire ecosystem.
Okay, so let's dive into the bits and nuts of channel selection here.
So channel selection is, I think, a really great first start for coexistence. And this is where an LAA network would take a look at the spectrum band before selecting a channel and try and select a channel that might have less traffic. So this is a good start, but we've done tests in 48 different locations at CableLabs, and we already see evidence of co-channel interference, and therefore more than just channel selection is required. And we'll take a look at that on the next slide.
Yeah.
And one of the possible approaches, and this is actually a fairly popular approach with some stakeholders, is the concept of applying LAA-LTE traffic channels with a duty cycle of a certain time period and then percentage of duty cycle how much the traffic is on. So for example, if the time frame is a 400 millisecond period, LTE might be on for 200 milliseconds and off for 200 milliseconds for 50%. And exactly how the duty cycle and period might be done could be vendor implementation, or it could be managed by the operator. But how that duty cycle is applied actually will have critical performance impacts on Wi-Fi as well as other LAA-LTE networks. Let's take a look at the next slide. So these are some brief test results we've done here at CableLabs with prototype duty cycle approaches. So of course, the wider the duty cycle, the lower the throughput is on other networks. So for example, taking a look at the third line down, with a 50% duty cycle, Wi-Fi or other networks in the band would experience a little bit more than 50% reduction of throughput. Contrasting that with contrasting that with the next slide is latency. So you could potentially have more efficiency and more throughput with bigger duty cycle time periods. However, that would have an impact of latency as shown in this diagram, whereas a duty cycle period of even 100 milliseconds can introduce latencies on other traffic which would exceed 50 or 100 milliseconds, particularly when you get up to 200 millisecond duty cycle time. And this could have impact on Wi-Fi, voice over Wi-Fi performance, or other real-time services over Wi-Fi. And so the duty cycles, how that's selected, could impact the nature of the services available to Wi-Fi users or even other LAA-LTE networks in the band. The next slide.
Yeah, that seems to be quite disruptive.
And so another key characteristics we think for coexistence would be listen before talk. And listen before talk actually includes a number of features. For example, sensing the carrier before applying traffic, and then only applying traffic when the carrier is free. Certain maximum channel occupancy requirements. And finally, how to back off from collisions, to recover from collisions on the spectrum that you're sharing with other networks. So Wi-Fi has a very highly specified mechanism for this that's used consistently in all regions of the world. And we would like to see that a consistent use of listen before talk amongst all technologies within the unlicensed band. And you might be tempted to say, well, we could just rely on regulations. So what this chart takes a look at is the impact or the implications of meeting only the minimum regulatory requirements in Europe. So for example, in Europe they have listen before talk regulations. Actually in the US and China they don't. But if you were to follow the European regulations, they're a little bit more, not quite as rigorous as Wi-Fi. So if you do a test or a simulation where you have two Wi-Fi networks and you measure a baseline performance, for example 1x, the green bar here, and if you replace one of those networks with an LAA network that only met the European regulations, the other LAA network would substantially reduce the Wi-Fi performance down to about 23%, and then the LAA would be well over the 1x baseline that we previously measured. So therefore, existing regulations are not really sufficient to ensure coexistence of all technologies in the band.
Well, that's certainly worrying. As a result of that, should the Wi-Fi community embrace LLA, or should it have a more defensive attitude?
Yeah, that's a very good question. And given the benefits of LAA-LTE, that if it's designed properly, it could actually make for greater throughput for all users in the band, both the LAA and potentially Wi-Fi, with strong coexistence. So I think that probably the best answer is for the stakeholders of both communities, the LAA-LTE communities and the Wi-Fi communities, and other communities that use the unlicensed bands to work together to develop strong coexistence requirements that can be applied across technologies. Those would include adaptive channel selection, consistent listen before talk, maximum channel occupancy requirements, and of course in-device coexistence techniques. So for a single standard solution, this is something that the communities can work together to achieve. And I think finally, we might want to consider an LTE configuration that can stand alone in unlicensed bands without the need for licensed spectrum, because that would allow for even more operators and more users to make use of the technology, which would increase the ecosystem for LAA-LTE.
This is great. Well, this is a great summary of this important issue that's being discussed. I want to thank you, Bernie, for answering my question. I want to thank the audience for listening, and I'll see you at the next Wi-Fi 360 Prime interview. Thank you very much.
Thank you very much for the opportunity, and have a good day.